For decades, India sat at the top of a very expensive list. It was one of the world's largest buyers of foreign military equipment. Relying on imported hardware meant depending on foreign supply chains, where another country could control your military readiness by simply turning off the tap. Take a look at this chart. By the 2025-26 financial year, India's domestic defense production spiked to a record 1.78 lakh crore rupees. Watch the map overlay. Export growth hit 62. Founded in 1958, the DRDO was tasked with building domestic alternatives to foreign tech. Today, that effort has grown into a network of 41 specialized laboratories, spanning everything from aeronautics to electronic warfare. To replace foreign imports, India first had to prove it could design complex kinetic weapons. The Agni missile series demonstrates this capability, giving India mastery over its own long-range strategic delivery systems. Meanwhile, in the aerospace sector, the HAL Tejas fighter jet program forced the country to develop a domestic manufacturing and avionics ecosystem, proving they could handle advanced flight control technology and composite materials. Ground forces saw similar advancements. The Pinaka system proved that India could conceptualize, engineer, and deploy heavy, multi-barrel artillery platforms in-house. By successfully fielding long-range missiles, modern fighter jets, and heavy artillery, Indian scientists and engineers confirmed they had the engineering capacity required to replace imported hardware. But traditional hardware, like tanks and jets, only represent one part of the challenge. The modern battlefield is increasingly software-driven, relying on data networks and autonomous operations. India is pursuing this next generation of technology under Mission Divyastra, which tested indigenous MIRV technology. MIRV stands for Multiple Independently Targetable Reentry Vehicles. In short, one missile can carry multiple warheads and direct each one to a different target simultaneously. The military is also integrating artificial intelligence and autonomous drones into their operations. AI systems analyze massive amounts of battlefield data to offer suspicious activity detection and target identification far faster than a human operator could. Supporting these systems requires domestic radar and electronic warfare units designed specifically to detect, protect, or disrupt enemy electromagnetic networks. In this environment, the speed at which a military can process information and jam an opponent's communications provides a tactical advantage as significant as the speed of a physical weapon. Inventing state-of-the-art tech in a government lab is a major achievement, but building a military requires the capacity to manufacture thousands of units. Transitioning from a single prototype to full-scale deployment depends on an established industrial base. This pie chart illustrates the shift in how India produces weapons. Public sector organizations still hold 76% of the output, but private companies have claimed a 24% share, equating to 42,000 crore rupee contribution in 2025-26. That private sector expansion accelerated on August 25, 2026, when Defense Minister Rajnath Singh approved handing over DRDO conventional missile technology directly to domestic private companies, moving tech from the lab straight to the factory floor. At the same time, programs like IDEX fund private startups and tech entrepreneurs to solve specific, real-world problems for the armed forces. By dismantling the government monopoly and building this network, linking universities and startups to massive private manufacturers, India created the infrastructure necessary for mass production. With a domestic supply chain now producing hardware, India arrived at the final phase of its strategic blueprint, pushing these domestic platforms into the global market. Look at this line graph tracking export revenue. In the 2013-14 financial year, India exported 686 crore rupees of defense equipment. By 2025-26, that number reached 38,424 crore. 80 countries now incorporate these systems into their own national defense strategies, placing Indian hardware alongside established global contractors in an increasingly competitive market. The government has set targets for 2029 to reach 3 lakh crore in annual production and push exports past 50,000 crore, while simultaneously investing in emerging technologies like secure quantum communications and directed energy weapons. The development of this self-reliant ecosystem removes the external dependencies that once constrained Indian military planning. This shift ensures that the country's defense readiness is governed by its own industrial capacity, rather than foreign supply chains.